So we're discussing what today?
Functions.
Functions. And how do you spell functions? F-U-N.
You can find fun in this.
Huh?
You can find the letter fun in this.
Right, fun. And then C-T-I-O-N. Okay? Now, do you have an idea about what the word function means?
The word function means, the English word for function means, is it functioning properly? Is it working properly?
So it has the word work
Yes.
with it, right?
Yes.
So if we say something's functional, what does that mean?
Means it's good and working.
Right, it's working, good and working and workable, right?
Yeah.
So it's interesting how mathematics
Yeah.
also has that kind of impression of working, workable, good and working, like you said, functioning, yeah? Now, this is why. Let us say, I tell you, y equals 2x plus 3, right? And now that looks like an equation, doesn't it?
Yep.
Now I draw that on a graph, and I'm just saying that maybe the graph is something like this. I don't know. Okay? The x-axis and a y-axis, right? Now tell me, if you remember, still, don't get scared, just be cool, okay? Which axis do you start considering first?
Which axis do we start considering first?
Or in other words, which is the independent variable?
The x.
The x, good. So x is independent. What does it mean, independent?
Independent means he knows he can do it. He's independent, and he has a strong will that he knows he can do it.
No. True.
That's what you can say in English.
But the word independent means you're free.
Yes.
What does Independence Day mean? Dana?
Independence, yeah.
So it's free.
day.
Free, meaning he can.
Means grocery shopping is free.
The grocery shopping is free. So it means the x can take values of anything. It's free to take values. It's independent running. And therefore y is dependent. What is the word?
It's dependent on x.
It's dependent on x. Very good. So that means if we change something here in our x, where will the change be?
And y.
And y. Good. And that can be shown in the graph, right? If you go here, you go up to this, go here for x, go up to that, right? And the corresponding y value is here, y value is here. So if this is your time, for example, time, and y probably is a car moving, right? Then with the more time passes, the farther away the car moves, right? Or this could be maybe even your force, right? And give me an example here with force.
Let me see. Force
Is your independent
Oh, I understand. Force is the dependent, right?
No, force is the independent.
Oh yeah, force is the independent. So the dependent could be pushing the car out of the mud.
Right, pushing the car out of the mud. Good example. So what will be an example, like a real example? The more force.
The more force put to a car to get out of a mud pit is
Right.
going to be the car getting out of the mud pit.
The more and more getting out of the mud pit, right? So you have your dependent and independent variable. Very good. Now, if you look at the equation again, let's look at the equation 2x plus 3. Now we know this was our independent, and as a result, this was our dependent, this variable depending on this, right? Now, can you tell me, thinking about your example with force and car getting out of the mud pit, okay? What made the car functioning?
As in?
Okay, focus. Okay, sometimes you go out of focus, and that's when you ask those questions. Okay, focus. Look at where my pen is. Okay, you're applying force, and the car is getting out of the mud pit. That's what you said. So what's making the car functional?
The force.
See, the force, right? So if we talk in terms of independent and dependent variables, like mathematical terms, which one was making the thing functioning?
Which one's making the thing functioning? The force.
Yes, if you got out of focus again because you're licking your fingers. Okay, you got to think when I show you examples, when I draw something, you have to be in the situation. Like you are pushing the car out of the mud pit. You're applying the force. You have to be in that position, otherwise you'll get out of focus. So I said, if we talk in terms of independent and dependent focus again.
I'm focusing.
Okay, if you're thinking about dependent and independent variables,
Yes.
then what is making this equation functioning?
The x. What is making this equation function?
The x. And the x is what variable?
The x is what variable? 2x.
What variable is the x?
What variable is the x? Independent.
Focus. Take a say. Independent variable. Okay?
Yes.
And the y is?
Dependent.
So what makes, again, final question, okay? What makes an equation function? Is it the independent or the dependent?
Independent.
Independent, okay? Now, let's get back here, and let's say your x is the force,
Yes.
and the equation as we have been writing it repeatedly in the same way, 2x plus 3, okay?
Yes.
If this is what is making this function,
Yes.
or functional actually, then let's say I change the value first to 1 plus 3, then I make it 3, then I make it, what am I doing here? What am I doing?
What are you doing? You're writing the values of x.
Good. I'm writing the values of x. I'm writing the values of x. So I'm changing the values of x. If you look at the graph, it's just going tuk 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 like, and we're expecting more of the car getting out of the mud pit. Yes. So you're right. I'm writing the values of x, and the x is, remember, it's independent. It can take any values, right?
Yes.
It's independent, taking 1, 2, 3, 4. I'm just selecting 1, 2, 3, 4.
So this, give me the pen for 1 second. So this could be like 3 in y, right? Right? 1 could be 3
Did you
in
calculate
y.
it, or what are you doing? Did you calculate the whole thing, or are you just writing randomly y?
I'm just writing randomly y for the example I'm trying to show.
How can you write randomly y? Because this side and this side should be the same. It's an equation. And this value is dependent on what is going on in here.
Let me just see this for 1 second. Let me... So this should be 5.
Yes.
So 5.
That's why it's called dependent.
7, 9, 11.
That is why it is called dependent, because these values came out of these values in x. You couldn't write this value first. I didn't write this value first. Did you notice that? I was writing the values of x first. I wasn't writing the y. Why? Because I know that the values of y will come only after we change the x's. So independently the x was changing. Based on that change, this is what the change was. You also can notice that this part here didn't change. It was all the same, right? So it was only dependent on this.
On the x.
On the x. It was only dependent on this. That means this entire equation was, what was running the equation?
The X as a motor.
Right, like a motor. It was running the equation. Now that's where we use the word function. The entire thing was being functional or made to function by the independent variable, right?
Right.
So instead of writing y equals 2x plus 3, they write function of x equals 2x plus 3. Does it make sense? Just look at it. I'm not going to tell you anything about the notation or anything. Just tell me, looking at it, thinking about it, does this symbol, this is just a symbol.
Yes.
Does it make
Y
sense?
is a function of X.
Exactly. Now you got the idea. Y is a function of x. And does it make sense? Like
Yes,
exact
it
mathematics?
makes sense.
Good point. That is a good observation. See, when you focus, you're really brilliant. Okay? Now, what does it tell you? Now, you said y is a function of x. So we could have actually wrote it this way. Written this way. Look. You can go higher. Y equals a function of x. That's exactly what you said. Y equals function of x. See?
Yes.
That makes sense, right? So instead of writing the entire equation like this, we could just write this. And that is valid. So in higher mathematics, that's what they do. They don't write this whole equation. They just write this. But of course, you gotta know what that equation means, right? Otherwise you can say it. But having said the same thing, this is true, which is also equal to 2x plus 3, right? Because y was this. So if y equals function of x, then that must be equal to 2x plus 3, like what we're doing.
Yeah.
Brilliant. So if we look at the graphical way of saying it, and remember this was our kind of like graph,
Yeah.
we would say this graph is nothing but a function of x. Simple.
So X is making this graph in the direction it should pinpoint out.
Exactly. And we just write this graph as y equals function of x. That's the graph. Remember, when you're using your calculator to write equations, it
Yes.
says y equals, and then it doesn't say anything else, right?
Yeah.
That's when you're putting the equation there. Actually, you're putting the function of x there.
Yes.
Okay?
And that calculator draws graphs.
Right. Now, if someone asks you, okay, very good, I understand y equals function of x. What if function of x equals 2x plus 3, like the equation you're using? Now, again, I'm not gonna tell you, I'm not gonna tell you, and I'm sure you can figure it out because I know you're smart. If function of x equals 2x plus 3, find the value of function of 4. Let's see now how you do it. I'm not telling you even how to do it. Just
Function of 4. Anything I want to do.
let's see if you can, if it makes sense. First, look at what's happening here. Function of x, like we said, is 2x plus 3. So that
Well,
must be,
Papa, just wait. So, if this is the function of 4, then X must equal to 4.
precisely, and that's why I didn't want to teach you, because these are so intuitive. Okay?
And so, since
So do it,
just,
do it.
just wait. I want to tell you something. Since this is multiplied to this, this is 4 multiplied by this, 8 plus 3 or 11.
Do it. I'm saying just show how you'll
Okay.
do it. Good.
2, 4. This is not 24, so I'm putting this sign here.
That's right.
Plus 3. And this equals. Should I write it here?
So the equal sign still stays there, and that's the other side of the equation.
So this is going to be 8 plus 3 or equals to 11.
Exactly. And I told you to change your style of writing the digit 1. Remember? That digit 1 doesn't even look like a good digit 1, okay? Anyway, so 11. Alright? Now, did you understand what's going on in here? I know you understood precisely. And now looking at the graph again, okay? That would only mean what? We go for function of 4 would mean going up to probably 4 steps.
Yeah.
Going up the equation, finding the value of y. So this is where your function of 4 is. Right?
We could have a graph here. I think.
No, this is function of 4 at this point. Okay? And when it is function of 4, what is y? Looking at this equation, what do you think y is?
What do you think y is? Something that depends on 4?
Yeah, you actually got the y. Come on, remember? This is your y equals.
Yes.
Y equals. So y equals what?
Y equals 8 plus 3. That equals to 11.
11. So this must be 11. This point here must be 11. So the coordinate right at this point is
Hey, let's
8
do the
and
graph.
11.
Let's do an actual graph about that. Like the whole equation.
Right now?
Yeah, let's just do it. It's small, right?
Okay. This is what I'll do. Alright, maybe just bring your calculator.
Okay.
Alright, so now we're going to use the graphic display calculator on our Android tab.
Yes.
And, okay, you're going to find the equation, right? Okay. You may want to clear that up first.
Yeah, I know that. Clear. Let me just clear this one. Clear. I'll just write here, okay?
There are too many equations there. It's going to show all of them, Papa. Not going to look good.
Okay, I'll just clear some more. Clear.
There should be a clear all window or something.
Yeah, you're right about that. Clear.
Alright, anyway, good. Okay. Alright. Make your graph. Use the first y, the y1.
The y1? Yes, so how do I have to write this? Y equals
2x plus 3.
2x plus 3, so it was 2x plus 3
equals, oh, graph.
Yeah,
You're right, graph. Okay, just we wait for it. There you go. There's the graph going. Beautiful. Okay.
Yeah.
Now, if you want to find the value of, you said 4, right?
Yep.
The way we do it is we say trace. We trace a point. Okay. So there, you see that button, trace?
Yeah.
So that means we're going to trace a point, right?
Okay.
Now you see when you click trace, it becomes x0, y3 right over here. That's what it's showing point there, okay?
Yeah.
x0, y3. Now if you put any value here, that should show you the corresponding value of y, okay? Now you gotta press what, just a 4, and it will show you x4. See x4? And you click again trace, or you can click enter.
Enter, okay.
It's down here. Enter.
Enter.
Oops, it says wrong. Maybe we're wrong in there. Maybe. Wait. Maybe we just should have pressed trace. Sometimes forget these things. Okay, trace, and then say 4. Trace again. Wait, that should work. Why isn't it working? We gotta relearn this calculator, Baba. Okay. 4. Bad, invalid, whatever. Okay, we're not gonna spend much time here, but we'll have to find a way so that it can trace. But let me tell you this.
Did you even realize no one is even looking at the screen of this?
Okay. Alright, let's not spend a lot of time with this.
Okay, we'll do it later, right?
Yes, we'll do it later. Yes, we're gonna find it out, don't worry. Okay, now, the point I'm going at, and you actually got it already so perfectly, so nicely, even without me telling you, is we can, for a function to, if there's a function like this, function of x equals 3x plus 3x squared plus 9x plus 3. And then I ask you, what is the function of 2? Just from what you did before.
Acha, so I could write 3 2 squared.
3 times 2 squared.
Yes.
Then
Plus 9 times 2 plus 3.
good. Now can you figure out the value? By the way, this is also y equals, right?
Yeah.
So we're putting a specific value of the independent variable to
That's
get
right. I'm just doing this math, okay? So 3 dot 2 dot 2 plus 9 times 2 is 18. So 18 plus 3 now equals to 6, 12 plus 18 plus 3 or as in 2, and this is equal to 33.
That's equal to 33.
Yeah, this is 30, this is 3.
All right, fascinating. Okay, so we just figured out from this equation here, which is a function of x, and we know that what was making it functional here?
What was making this functional here?
It's this x, the independent variable. So for a specific value on the curve,
it will make a specific
value of
the curve.
No, we have, so an equation is a curve, remember?
Yes.
So an equation, perhaps this equation is going to look something like this, I don't know. Okay? Yeah, it's because it has a square, it should look like a parabola. And so we're finding the value of where x equals 2. 1, 2, there. And that's probably where y is going to be. But of course we can see that it's not going to be here, it's going to be somewhere up there because it's 33, right? So our graph is wrong. We can even say it from here. But what it's trying to say is for a specific point of x, what did we find? The value of what?
You found the value of x.
The specific value of x is 2, so we found the value of?
The specific value of x is 2, so we found the value of y.
Here, don't lose focus, Baba.
Okay.
I know when you lose focus, I can tell, because you're not supposed to answer weirdo things, okay? Now, what is the use of finding the specific value of x, the specific value of y? What is the use?
We can pinpoint out the dots so we can make the graph, and sometimes these graphs are actually useful rather than our random explanation or example, right?
Exactly. So
sometimes it's used in real life for about many things. How long you can stay in this thing, do this thing, and many things like this.
Right. So what we do with finding specific points of x and then y is, let's say I ask you, hey Ridwan, can you tell me what this point is on a two-dimensional space?
Like an area?
No. What this point is. The point is not an area. A point is...
Yeah.
Can you tell me how do you specify that point in there?
How do I specify the point here?
With a coordinate system.
Yeah, we do need actually coordinates to know this specific...
That's what they do in mathematics, and that's called a Cartesian mathematics. Okay, this is a Cartesian mathematics where you have x-axis and y-axis. You know why it's called Cartesian?
Why?
Because there was this philosopher, actually a mathematician. His name was Descartes. Descartes discovered how to specify a point in space, like in a two-dimension, and that's why it's named after him, Cartesian. Okay, so if we know how to pinpoint a point, that's helpful because sometimes we want to know specific values. I have a graph of, let's say, the strength of the steel here. Okay, the steel here. I know how much force it can take before it will bend, right? And then I make a graph of that. Put a force little here, bending there. Put a force little here, bending here. Put a force little here, bending here. I make a curve like this. And because it's a curve, it is also an equation.
Yes.
Right? So in the equation, I can say, okay, how about I put here 5 newtons of force,
Yes.
how much will it bend? You can tell it from here, right? Because you know
Yeah.
it's an independent value. So that's why it's sometimes useful. And this is function, by the way. And it can go even more complex. Look, for example, it can go like this. Function of x equals something like this. 2x plus 3x squared divided by 5x. But it's the same. If I say function of 3, all you do is 2 times 3 plus 3 times 3 squared plus 5 times 3. What did I do? Just place the values of x.
So let me just see this first. I'm gonna write this in 1. So this equals to let me first put this here. This equals to 15, of course. Right? This equals to 15. This is going to be 6, and this is 3, right?
3 squared.
Yeah, 3 squared. So 3 times 3, 9 times 3 is 27. So 27 plus 6. 7 plus 6 is going to be 13 and 37, right?
What?
No. Plus 1. Okay, so 27 and 6 is going to be 33. So 33.
Good.
And we can already see that this equals to 2, right?
Yep.
2 full bars, and here's the 15, and this is going to be 3.
But you can reduce it further.
Yes, if I cancel this and this, it'll be 5. So it's 1 over 5.
1/5. So 2n.
Is equals to 2 and 1/5.
Brilliant. So we just found the function of 3 for this equation here.
Yes.
So that's about function. There's really nothing more. It just gets complex
It's so
and complex.
easy?
It's so easy. It just gets a little more complex and complex with more things. For example, when you learn trigonometry, you'll see that the function is going to be the angles instead of x.
And the angles sometimes are weirdly curved, right?
The angles are always curved, Papa. Okay.
Weirdly.
Yeah, weirdly curved. Yes. So why is that going to be? Because this angle here, right? It makes sense this to be the independent variable, because with the change in angle, either you reach this point, or you reach this point, or you reach this point. So with the change in angle, you reach different points. So the different points are your dependent variable,
Yes.
which is dependent on the change in angle. So makes sense that the independent variable
Yes, I understood.
good. And we also always practice saying that the independent variable is with respect to the change. So that is the respect. The x is also said to be with respect to. So with respect to x, with respect to x, and with respect to x, right? And where is that more applied? Remember slopes? Y by x, the y component and the x component. We say that the rate of change of y with respect to x. That makes sense. With respect to force, something moves out. With respect to time, something goes out. So it's just about how we say it, okay? That's about all function, and we're just going to do complex problems later. Come on, let's check out the pre-calculus book. Hey, this is our pre-calculus book. Fun time. Howard Community.
Hey dude, it's almost 30 minutes on this video.
That's totally fine.
Totally fine with you.
I can cut it down. Look at this. So this is what I was trying to tell you. And you can do this math already. What does it say? Evaluate. It says evaluate function of -2 and function of 4 for this. What does that mean? Evaluate means just like I told you. So instead of using a function of x, use a function of 3, a function of 2. That the mathematical term is said to be evaluate. So we just place function of instead of function of x, we put -2 here and then here, and you can already see the result here. Tell me what the result is going to be with this one. A function of x equals x plus 2. What is function of?
Function of x is gonna be 0.
Wonderful. See, you're doing the first chapter of pre-calculus book, which is not at all difficult for you, okay? Now they gave you examples here discussing exactly the things that you've discussed before, slope and everything. We'll go there a little later, but first we're gonna do the function mathematics, okay? Tomorrow, not today, okay? Then we'll move on with this.
Okay, so that's about it for this video.
Yeah, look, this book is thick, but you think it's gonna be difficult for you? No, it's gonna be just easy. Once you learn the functions, it's just a piece of cake. Everything is just simple.
Hey, you should say piece of 3.14. Get it? Piece of pie?
Piece of pie.
Yeah.
A piece of pie.
Yeah, piece of 3.14.
Piece of 3.14. Okay, bye-bye. Hey, ciao.